Yes. Okay. What is the probability that the first die will have a natural number greater than 6? So for probability, it's always the total of combinations at the bottom and then probability of the event. So it's asking you for the die, for one die, so 6, right? So it would be out of 6 because there's only 6 sides to a die. And then it's asking you the natural number greater than 1. For a natural number greater than 1, it can only be divisible by 1 in itself. So a number that's only divisible by 1 in itself, so nothing else. So 4 is divisible by 2, so 4 would not be 1. And 1 is divisible by everything, so no. 6 is divisible by 3 and 2. So no. So 6 would not be 1, 4 would not be 1. So you'd only get 2, 3, and 5 because those are the only numbers that would be only divisible by 1 in itself. Because they're only divisible by themselves. So 2 can only be divisible by 1 and only by 2. 3 can only be divisible by 1 and only 3. 5 can be only divisible by 1 and only 5. So that's 3. That is 6. And that's the answer for 18. And now for 19, I was asking you, what is the probability that one die has the number 5 as the outcome and the other has 1 as the outcome? So what I do, is it's asking you like die. So one die, of course, is 1, 2, 3, 4, 5, 6. 6 sides to one die. 1, 2, 3, 4, 5, 6. But before you do all this, you need to find out the total combinations, right? So there's 2 die, 2 dice, dice plural. So that's 6 sides, right? Each. So 6 times 6 is 36. So the total number of combinations is 36. So it's gonna be out of 36. But now we need to find the one that has number 5 as an outcome and the other one as 5. You don't really need to do this because like this isn't that hard of a question, but I always do it because all the other questions kind of follow when it asks you for combinations. This is how I find all the combinations. So then I make my chart. Sure, it looks neat, not like this, but okay. So then I'm pretty sure you go 1, 2, 3, 4, 5, 6. I just I'm so bad at this. Yes, this is how you do. This is how you do. This is how you do. Let me pull up the lines for a second to make sure I'm doing it right. I'm butchering this song. Okay, I'm pretty sure it's like lecture 13. Damn, you already posted the new lectures. Wish Claire happy birthday. Sorry, I'm talking to myself. I'm trying to find. Okay. Normally, a probability question is always going to ask you a probability of event, right? And in this situation, it's about die. So die have 6 sides each, and you're going to have 2 dice. So 6 times 6 is 36. So the total number of combinations that you're going to have is 36. But now you need to find the probability of a specific event. So what I'm going to do is make a chart to find the total combinations. So make 1, 2, 3, 5, 6 like this, and 1, 2, 3, 4, 5, 6 like that. And you go 1, 2, 3, 4, 5, 6, and you just keep going. Just all the way. Wow, that was an ugly 3. Okay, then we go 1, 2, Just asking you the probability that one die is 1 and the other, the one is 5 and the other is 1. So we will look for 5 and 1, 5 and 1, 5 and 1. So there's only 1. That's 5 and 1. So the probability is 1 out of 36. Never mind, it is not. Disregard. 5, 1, 5. 2 out of 36. Right, 2 out of 36. And then you simplify it, it's 1 over 18. And that is the answer, as you see. And it's going to tell you what is the probability that the second die will have a number that is less than the number on the first die. So how I did that one is, you can look here, probability that the first die is 1 less than the other. And then so, of course you do and then you would just look and see what numbers are less than the first, sorry. And you look here to find the combinations that the first die is less than the second die. So for here, be like, no, first die is less than the second die. So this would be 1. No. First die, remember, first die is less than the second die. All of these. 5. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 die. For that question, 15 out of 36. Okay. And now for coin tosses, right? So of course, a coin has 2 sides. And you're tossing it 4 times, so that'd be 2, 4, 2 times 2 times 2 times 2, which is obviously equal to, I'm embarrassed, 16. Okay, that's the total combinations. Right. But now we want to find those combinations, basically, all the combinations, so we can find the probability of what it's asking you. So how I do it is, since a coin has head, tails, right? It's asking you, there are 4 coins, right? So that's like the equivalent of 4 tosses. So I'm gonna find all of them. So we're gonna do 4s, tails, 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 find the combinations. Okay. Add. So that's 1. Add. To do add tails. Add tails. Great. So we did that. So then add tails. Head. And then do head, tails, head, tail, tail. Tail. And then head, tails, head. And then head, tails. Basically, you're just gonna keep going like 1, 2, 3, 4, 2, 3, dun, 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 until you get all the combinations possible. I hope that's helpful. So that's how I do it. I took the test. It asked me for this. And if it only asked you for 3, then you only do it 3 times. So you'd only do 1, 2, 3, and you would stop. You would stop here. You wouldn't do it another time because then that'd be more. Because then you'd do with 3, 12 combinations. If you tossed it 3 times, it would be different combination. So yes, I'll be back and I'll show you.